16.4c, finding the coordinates of the x and y intercepts algebraically for the equation y is equal to ax squared plus bx plus c. So today we're going to talk about how to find the x and y intercepts of quadratic equations. The x-intercept is the point where the parabola crosses the x-axis, and the y-intercept is the point where the parabola crosses the y-axis. Sometimes we can't just look at the graph of the parabola and tell the exact location of these points. If you'll notice here, for our x-intercepts, they're somewhere between 1 and 2, but they're not at an exact point where we can tell what it is. For this y-intercept here, it's a little less than where the 6 is, so we can't exactly tell what their intercepts are. So if that's the case, we have to find them algebraically. And we can find the coordinates of the intercepts by plugging in 0 for the opposite coordinate. For example, if I want to find the x-intercept, or where it crosses the x-axis, I would plug in 0 for y and then solve the equation, and that would give me my x-intercept. And then just the opposite is true. If I want to find my y-intercept, where it crosses the y-axis, I would plug in 0 for x and solve for y, and that would give me my y-intercept. So let's do that in this equation. All right, here we have a quadratic equation, and we're going to find the x-intercept by substituting in 0 for y, and then we have to solve the equation. It's a quadratic equation, so we have to use one of the methods that we've learned to solve the equation. We can either solve it by factoring, the square root method, or the quadratic formula. All right, so if I plug in 0 for y, I'm going to see if this is factorable. So this is a trinomial, which we know trinomials factor into two binomials. The only factors of 2 would be 2 and 1, so 2x and x would go in the first two spots. And the only factors of 3 are 3 and 1. Well, I know that I'm going to try to be getting 1, so I don't want to put the 3 here because that would multiply to give me a 6. So if I put the 3 here and a 1 here, then that's probably going to work. All right, this tells me the sign of the biggest product. So if I multiply these, I get 3, and if I multiply these, I get 2. So my biggest product is positive. Now, I want to check this and make sure that it factored correctly by doing my smiley face. This is a positive 3x, and this is a negative 2x, which gives me a positive x, and that's what I need it to be. Okay, so it factored correctly. And now I need to take each of these factors and set them equal to 0 and solve. Okay, so if I take my 2x plus 3, let me do it the other way. All right, 2x plus 3 equals 0. If I subtract 3 from both sides, I get 2x equals negative 3, and then divide by 2. So I get x equals negative 3 over 2. And then or we could say negative 1 and a half. All right, and then for my x minus 1 equals 0, all I do is add 1 to both sides, and I get x equals 1. So these would be my two x-intercepts. Now let's find the y-intercepts. They're usually easier. Oh, well, here's a place to write this. I didn't write this down. Okay, so negative 1 and a half and 1 would be my two x-intercepts. Now we're going to find the y-intercept by plugging in 0 for x. Okay, let's go back to the equation. All right, let's do it right here. There's a little more room. Y-intercept. So if I plug in 0 for my x values, all of this goes away because 0 squared is 0, 2 times 0 is 0, And 0 plus 0 is 0. So all of that turns to 0, and I just get y equals negative 3. Oh, okay. Well, I didn't write this correctly. So this asks for the coordinates of my x-intercepts. So it should be negative 1.5, 0, and 1, 0. Okay, then for my y-intercept, it would be 0, negative 3. There we go. All right, find the x and y intercepts algebraically for this quadratic equation. So for my x-intercept, plug in 0 for y. Okay, and to factor this, let me just show you something that would make this a whole lot easier. If I have a negative, just a negative as my a value, I can, if I were to move all of this over to the other side or just factor out a negative 1, that's going to change all of these values. So as long as I change the sign of everything in the equation, then it's equivalent. So I could just say I'm dividing everything by negative 1. Well, if I divide 0 by negative 1, I still get 0. If I divide all of these by negative 1, it's just going to change every sign. And these two equations are equivalent because I changed every sign, it's equivalent. And now that makes this easier to factor because I don't have that negative in front. Okay, so I'm going to do the factors of x squared, which are x and x. The factors of 3 are 1 and 3. This tells me my signs are the same, and this tells me what they are. All right, and if I did my smiley face, that's a negative 1x and a negative 3x, which gives me a negative 4x. So now I set each one of these equal to 0 and solve. And add 1, and I get x equals 1. And x equals 3. So the coordinates of my x-intercepts are 1, 0, and 3, 0. Now for the coordinates of the y-intercept, I plug in 0 for my x's. And just like before, the zeros, this is 0, negative 0 squared is 0. And 4 times 0 is 0, so all of that turns to a 0, and I get y equals negative 3. So my y-intercept is 0, negative 3. All right, we're going to do one more. To find the x-intercepts, I'm plugging in 0, and I have x squared minus 1. All right, so to factor this is a difference of perfect squares. So this would factor into x plus 1, x minus 1. All right, and then I set each one of those equal to 0 and solve. If I subtract 1 from both sides, I get negative 1. If I add 1 to both sides, I get positive 1. So the coordinates of my x-intercepts are negative 1, 0, and 1, 0. Then for my y-intercept, y equals 0 squared minus 1. Well, that goes away, and I get y equals negative 1. So my y-intercept is 0, negative 1. And that's how we find the vertex for our quadratic equations algebraically.